All right. So Phalgun and I are really excited to share our research with you today. We're going to be talking about the Windows Search Index because we believe that it's the forensic artifact that you've been searching for. All right.
Hi all, I am Phalgun Kulkarni and I work at Aon delivering Strauss Friedberg's incident response and digital forensic services. At Strauss Friedberg, I work on multiple cyber incidents such as ransomware, threat hunts, and APTs. And in my free time, I love researching forensic artifacts.
And I'm Julia. I'm a software developer. I focus on DFIR and threat intel, and I work closely with Phalgun and everyone else on the DFIR team, building tools that make their jobs a little bit easier. We work on a wide range of cases and we have a really talented team. And that gives us the opportunity to pursue research like the research we've done today, or that we're sharing with you today at this conference.
So why should you listen to us? We have been thoroughly researching Windows Search Index and have a good understanding of this artifact. We emulated multiple scenarios faced during DFIR investigations and were amazed by the wealth of information we could recover just from a single artifact. We wanted to share those amazing insights with you to help you enhance your analysis. So by the end of this talk, you will have a good understanding of how Windows Search Index can help answer questions associated with files and folders present on a system, metadata from non-existing files, as well as historical activity associated with internet browsing. And let's set the agenda for this talk. We begin by introducing Windows Search Index and how it works. We talk about what data is stored and how it's structured in the database. We quickly introduce and discuss what changes were made to Windows Search Index in Windows 11 operating system. And the most interesting part, the forensic value held by Windows Search Index artifact, and I'm sure you're gonna love this part. Last but definitely not the least, we showcase Search Index Database Reporter, or CIDR, Strauss Friedberg's open source tool to parse Windows Search Index effectively and at scale. But before we move on, I wanted to take a minute to explain what Windows forensic artifacts are. I know we are at SANS and most of you know this, but I just wanted to level set things. So Windows introduces features which are aimed toward enhancing user experience, like Kevin mentioned. So let's say, for example, jump lists, which can be used to switch between multiple files, and prefetch can shorten the startup time taken by an application. But on the flip side, jump lists can be used to prove file access, and prefetch can be used as a source of evidence to prove program execution. Similarly, Windows Search Index exists on a machine for users to be able to search for files. But on the other hand, it also contains a lot of data which can help us in our investigations. So let's see how Windows Search Index works.
Okay, so let's talk about how Microsoft markets this feature to the average user. To the average user, the Windows Search Index is exposed as the search bar that you see when you click on the Windows Start menu, and you can use it to search for anything, anywhere, and all at once, because you can use file names and contents of files to search for files on your system. You can also use it to search through your browser history, and you can use it to search the web. The Windows Search Index is also implemented differently in other apps. So Microsoft Photos will use it to track changes in your files. Cortana will use it to give you search results. If you're searching for an email using the Outlook search bar, Outlook is using the Windows Search Index in the backend to search through the emails on your system. And other apps in the Microsoft Store will implement it in different ways. So how does it work? Well, let's say you're the average user and you're looking for an invoice that you created a week ago, but you can't find it. So you query the search box, which queries the Windows Search Index. And before all this happened, the Windows Search Service is periodically extracting information from files and index locations, and it's cataloging this information in the Windows Search Index database. So the Windows Search Index database comes back and it says, Your invoice is in your documents folder. And as the user, you're eternally grateful for how helpful the Windows Search Index is.
All right, thanks, Julia. Now that we know how Windows Search Index works, let's see what data is stored and how it's structured in the database. So Windows Search Indexer service will index files and folders from two directories, C users and start menu programs. There is one exception though. Files and folders from C users app data directory will be excluded by default. So these indexed files and folders are stored in a database, which can be found at C program data, Microsoft Search, data applications, Windows directory. So let's see how this database looks like. Beginning from Windows Vista until Windows 10, the database sits in a file named windows.edb. Windows.edb is in an extensible storage engine format, which is similar to that of the user access logs format. An important point to note, Windows Search Index service will be enabled by default only on the Windows endpoint operating systems and not on the Windows Server operating systems. So out of the entire windows.edb file, we have identified three most useful tables which can help us in our investigations. So let's discuss them briefly. Beginning with system index gather table. Now this table contains multiple columns, but we have identified three to be the most useful ones. Gather table will contain file name and last modified timestamp of every file and folder indexed from the two mentioned directories. It will also contain scope ID column, which is an integer assigned to every record, which can also be used to determine a files or folders parent-child relationship. Next, we have the gather path table. Now this table only contains of three columns, and those three columns only contain the information about parent files or folders of the files being indexed in the gather table, which we talked about previously. We can correlate the scope ID column from the gather table with the columns present in the gather path table to form or determine a files or folders parent-child relationship. All right, now let's get into the meat and potatoes of Windows Search Index, which is the property store table. Now this table is most amazing and important one, and you will see why. As we all know, timestamps can be one of the most important factors in any given investigation. The property store table not only stores the modified, access, and created timestamps, but it also stores the search gather timestamp. Now, this is the time when Windows Search Indexer service will index a file being created or being modified on a system. So basically, any changes made to a file will reflect on the gather time. Now, this can be an important source of evidence if you want to cross-verify a few timestamps from your investigations. Next, we have the file owner and full path of the file being indexed. Again, this can be important when attributing a particular user to a file, thus proving file knowledge or even file access. And lastly, the most amazing feature of property store table is the search auto summary feature. Now it's amazing because it contains partial file content. So let's say, for example, if a threat actor deletes a configuration file which may have been associated with a tool used for data exfiltration. Now that config file may not exist on the disk, but we may be able to recover partial content from the config file by enumerating the search auto summary feature. Now, isn't that cool? And if we are lucky, we might even get the IP address associated with that data exfiltration. And Julia will be covering deleted file metadata and content in the upcoming slides in detail. And this is why the property store table is an amazing and important table. So let's see how windows.edb file looks like. We use Nearsoft's EAC database view to open the windows.edb file. And as you can see, all the ducks are in a row. Each record has its separate row, and the columns are categorized by various file properties. But let's consider a scenario where you upgrade your network to host Windows 11 operating systems. And now you want to analyze Windows Search Index and you search for windows.edb file, but you couldn't find one. You ask why? Because Microsoft introduced changes to Windows Search Index in Windows 11. Now, windows.edb file is divided into three SQLite databases, namely Windows Gather, Windows, and Windows USN.db files. So Windows USN.db file is still being tested upon and is out of the scope of this presentation. So basically, data remains the same, but format is changed from Windows 10 to 11. And let's compare that real quick. So as you can see, in Windows 10 or in windows.edb file, all the tables are in a single database. But in Windows 11, the gather and gather path tables are now stored in the Windows gather DB file. And importantly, the property store table is now split into two, namely property store and property store metadata tables. So let's quickly take a look at how windows.db file looks like. We use DB browser for SQLite to open windows.db file. And as you can see, all the ducks are not in a row. Each record may have multiple rows of its own. And the property store table has 3 columns. Work ID represents each unique record, and column ID contains values which can be mapped to respective file properties in the property store metadata table. So let's say, for example, in the property store row 1 of the column ID column, we have value 13, which when mapped to the property store metadata table tells us that the value 13 represents system is folder, and thus we know record with work ID 1 is a folder. And similarly, we can map all the values in the column ID to respective properties in the property store metadata table.
Okay, so before we move on, I want to give you all a quick note about ESE databases. Phalgun mentioned some differences between Windows 10, Windows 11, and the search index, how the index is structured in those operating systems. But especially in Windows 10, there's some things you should know about ESE databases in particular. So ESE databases can be dirty. What do I mean by that? Well, I mean that they can be in an inconsistent state. The reason why is because they were made for many near simultaneous transactions or many database reads and writes happening at the same time. So in a perfect world, a file is created and then that file record is immediately added to our database. But in the case of ESE databases, that's not how it works. Instead, the file is created, that file record is added to a log buffer, which exists in memory. And that log buffer is pretty small. So once it gets full, a log file will be written to disk. And normally those log files are periodically written to the database. But if you perform a live image or your system experiences a catastrophic shutdown, those log files may not be written to the database and you end up with a dirty database. Why do we care? Well, as forensic investigators, a lot of the tools that we use to parse these sorts of databases are relying on a clean database. If you try to use one of these tools to parse a dirty database, either the tool may not run at all, or you may get inaccurate information because you haven't replayed those log files to the database. But thankfully, there's a built-in Windows tool called ESENT-util that you can use to perform recovery and repair a database if it's damaged or corrupted. There's a couple commands that I want to bring your attention to. /R will perform recovery and replay those logs to the database. /P will repair a damaged or corrupted database. Some of you may be catching on to this, but one important thing to remember is that those log files are also going to contain deletions, right? So if you replay those logs to your database in order to clean it, you may miss some records that were deleted, and that may be of importance to you in your investigation. So one thing you can do is you can parse both the clean and the dirty database if you can, and figure out if there's any differences there so that you can kind of get the complete picture. One caveat of this is that if for some reason you're working on a Windows 7 system in order to to do forensic analysis, you cannot use that system to clean a .edb file that originated on a newer operating system. So for example, you can't use a Windows 7 system to clean a Windows 10 EDB because the ESC engine on the Windows 7 system won't be able to clean that newer database. Okay, so that was quite a bit of technical information, but hopefully this next part you'll like a bit more. We're going to talk about the forensic value of the index as well as some use cases. Okay, so let's start with file and folder enumeration and how we can use that feature in our investigations. So just to recap, anytime you create a file or folder in an index location, a file record is created and it's placed in the Windows Search Index database. This file record is going to include metadata like the full path of the file, timestamps associated with the file attributes like file type and file owner, as well as the index gather time, which, as Phalgun mentioned before, is any time the file record was updated and therefore re-indexed. So let's think of some examples where this information will be useful. Those of you that do IR work in particular may be familiar with the fact that threat actors love to stage files for exfiltration and drop malware in subfolders of C users, so any user folders. So with the search index, you can enumerate those files. If you're dealing with a user who wittingly or unwittingly downloaded malicious files, those files are likely going to end up in their downloads folder, and you can also use the index to enumerate that folder. Again, those of you in IR may also know that threat actors like to create startup tasks in order to gain persistence on a system, and those startup tasks will end up in this program startup folder. And thankfully, this folder is also enumerated with the index. Lastly, if you're doing a digital forensics investigation and you're investigating a suspicious user, that user may have created or deleted files that are important to your investigation, and you can enumerate those files using the index. Just really quick, some of you may be wondering, like, why do I care if I have access to the system if I have a full image? Well, sometimes you don't have a full image and you only have a triage collection, in which case you may not have the entire C user subfolders, right? So in this case, maybe you do have the Windows Search Index and you can use it along with other artifacts of file existence like the MFT to enumerate those files without actually having access to those files. Okay, so let's move on to auto summary. Phalgun mentioned this earlier, but I think this is the most interesting feature of the index. So like Phalgun mentioned, the auto summary feature will record partial file contents. And you may be thinking, like, this is the perfect tool for forensic investigators. There's no way this wasn't made especially for us. Well, the reason why Microsoft created this feature is so that you can search a file based on file contents. So I hid the word pineapple in this example. I hid the word pineapple at the end of this file, and I was able to find the file using File Explorer. So that's the whole reason why this feature exists. One caveat of this feature, the file extension has to match the file type in order for auto summary to accurately record the contents of the file. So if you save a plain text file as a PDF, auto summary thinks it's going to have to parse the PDF. It's not going to record the contents of that file. One thing we observed in our research is that in Windows 11, up to 1,024 bytes of file contents may be recorded. And some of you may be realizing if the file is small enough, that means you get the full contents of the file. So let's talk about what sorts of files have their content captured in the index. I'm not going to read out all of these, but some may stick out to you. In particular, if you're doing IR work and you're hunting for web shells on a system, .asp files are going to have their file contents indexed in the Windows Search Index. If you're working with a threat actor who's using batch files or command files or Visual Basic files, the contents of those files will also be included in the index. If you're looking at email files or Office files that are pertinent to an insider threat investigation, the contents of those files will also be in the index. Lastly, I know that a lot of you are wondering about whether the search index can help you recover deleted file metadata or deleted file contents. And like many things in forensics, the answer is it depends. We weren't able to get definitive results with our research, but what we did observe was that if we performed a live image of a system, we were more likely to get deleted file metadata as well as deleted file contents. So what you should take away from this is that if you have access to the Windows search index, you should check it because you may be able to recover contents or metadata of deleted files on the system.
Thanks, Julia, for walking us through one important aspect of Windows Search Index. Now let's take a look at another interesting aspect, which is internet browsing activity. So at times, investigators may need to analyze internet browsing activity, but may not have browsing artifacts at their disposal, or they may want to cross-verify their findings. So in Windows 10, activity conducted using Internet Explorer, and in Windows 11, activity conducted using Edge browser will be indexed in the search index database. Now, interestingly, we found out that successfully visited URLs will be stored in the item path display column of the property store table, and unsuccessfully visited URLs, meaning if the URL did not exist, let's say, for example, 123 this website does not exist.com, or if the URL was visited without an active internet connection, then those URLs may be stored in the activity content URI or the activity description columns of the property store table in Windows 10. In contrast, in Windows 11 or Windows DB file, we found out that irrespective of how you access the URL, it will be stored in the system link target URL column of the property store table in Windows 11. Quickly wanted to highlight that we observed in our testing that some of the unsuccessfully visited URLs may not be present in the database all the time. Now that we know Windows Search Index can give us insights about internet browsing activity, the question has to arise, what if a user deletes their internet browsing activity? So in Windows 11, we tested by deleting the browsing activity from the browser, as well as by deleting the app data folder of Edge application. Now, interestingly, we were able to recover the entire browsing session. And as we can see, we can enumerate which URL was accessed, the type of history, as well as when it was accessed. Now, this can be really important if you do not have browsing artifacts at your disposal, or like I said, in cross-verifying your findings. But in contrast, in Windows 10 or EDB file, deleted browsing activity was sometimes present in the database, but not most of the times. And lastly, I wanted to highlight that internet browsing activity may also be present in the activity history feature of Windows Search Index. Now you may wonder, what is activity history? So let's talk about it. A Windows Search Index can tell you when you opened or closed the file, which program you use to interact with the file, as well as the file name itself. Now, how does it do that? Activity history feature tracks file opening or interaction per user. And what's fascinating is that even if the file is being deleted or being renamed, and if it was interacted with at some point, then that activity will still be present in the activity history records or feature. This can be really important in enumerating or attributing a user activity even for non-existing files. And we can identify activity history records by enumerating the system item type column and looking for the activity history item value in that column in the property store table. An important reminder, activity history is a subset of entire user activity. And if the record of activity is not present in the activity history, does not mean that activity did not occur. And again, wanted to highlight URLs accessed may be present in the activity history feature as well. So let's see what exactly is indexed. For example, if I interact with a PDF file using Firefox browser, the full path of the PDF file, including my SID or security identifier, start and end time or opening and closing time of that activity, as well as the program used to interact with the file will be indexed. Start and end times may vary by a few seconds, but they can be accurate sometimes. All right, remember I mentioned activity history feature is a subset of user activity. And you may wonder what gets indexed exactly. So we tested by interacting with few commonly used files, such as text format files, Open that with commonly used applications like Notepad or Notepad++, PDF files with most common browsers, and files like Excel and documents will be indexed in the activity history feature. As Julia mentioned, I wanted to quickly highlight that Windows Search Index will also contain email and Outlook related data, but that is out of the scope of this presentation.
All right, let's talk about a quick example because this is a lot of facts, but I want to show you all how this actually looks in practice. All right, so we created a malicious looking file, and you can tell it's malicious because there's an IP address in it. And then we checked the Windows search index, and we wanted to figure out if we could recover the file contents of that file. And there you have it. We have the entire file in auto summary because it's small enough, and you have that super scary looking IP address in there as well. So then we looked at activity history, and we wanted to figure out if we could get some information about our opening and closing of the file. So we were able to get the our user SID. We were able to get the name of the program that we used to open the file. We got the file name, and then we also got the start and end time for activity history, which corresponded with the time of file opening and closing. All right, so let's move on to CIDR. CIDR stands for Search Index Database Reporter, and it's the tool that our dev team built in the past few months to parse the search index at scale. So why did we choose to build this tool? Well, in our research, Phalgun and I noticed that it's kind of difficult to parse multiple indexes at the same time and compare our results. A lot of the GUI-based tools only let you load one index in at a time, so it just made our research a little bit more difficult. So we created a command line tool to parse Windows search indexes and to parse multiple indexes all in the same execution of the tool. So some features of the tool include the fact that it can parse both ESC and SQLite databases. So you can parse both Windows 10 and Windows 11 Windows Search Index databases in the same CIDR execution. Like I said, you can process the index at scale. You can process multiple indexes. It gives you readable output of the artifact. So you can choose between CSV and JSON format. And if you are doing a time-sensitive matter and you have tight deadlines, this tool is really fast because it's written in Rust, or that's one of the reasons why it's fast. It's written in Rust. It's open source on GitHub. So if any of you are developers and you're interested in contributing, I encourage you to take a look and open up some PRs for us. It's written in Apache 2.0 license. And if you don't feel like compiling it on your system, you can download a fresh build that we uploaded to GitHub today. All right, so how does it work? You call CIDR and you give it some options. You give it a output format. By default, it will do JSON, but you can also tell it to give you CSV output. You give it an output directory or where you want the output to go, but by default, it will use the current working directory. You can print a help message, which will include a summary, as well as this message that you see on the screen, and you can get the version number. And then you give it an input directory. Note that I say directory. You're not giving it the path to the actual database. You're giving it a path to a folder that is recursively scanned for any windows.db or windows.edb files that exist in there. So this is how it looks. Like I said, you call CIDR, you give it an output directory, a format, and the input directory. And it's super fast. I only parsed one Windows search index, so I got 3 separate reports. And the way that the reports are named is it starts with a host name. So if you parse multiple systems at the same time, you can differentiate them with the host name. And then it gives you the report type. So you have an activity history report, file report, and an internet history report. And then you have the timestamp of when the tool was run. So let's take a look at the output. If my clicker works, can you click me?
It's not working.
Is yours not working? Can we get the next slide, please? I can just talk about it. You guys don't have to see it. Thank you. Okay, so here is the file report. Let's say you're performing an investigation and you're uncovering a huge heist, and you find a file that's called Super Secret Evil Spreadsheet, and you find, thankfully, Cider gives you the auto summary in a neat little column in the CSV report, and you find that these people were going to steal a ton of money and they had already bought a bunch of private jets and a bunch of Lamborghinis. So thank you, Cider, for this beautiful file report where you can figure out that this happened on this system. You also get an activity history report. So like I said before, you get the user SID, you get the activity history start and end time, so file opening and closing. You get the name of the program used to perform that activity, and you get the file name. And lastly, you get an internet history report. So I have a few examples here. Let's say you have a insider threat case, and this person is Googling how to plagiarize, how to steal intellectual property on their work laptop. Well, you're gonna get the title of the website, the date and time of the access, and the link that they had accessed using Edge or Internet Explorer. If you have a user who was really unlucky and they clicked on a phishing link because they thought they were downloading their W-9, well, you'll see that in the Windows search index. You'll see the name of the website, the date and time of access, as well as the link that they clicked on. If you have a really incompetent threat actor and they're Googling how to evade detection on the system that they've compromised, you also see the title of that website, the timestamp, as well as the link. Lastly, if you have a threat actor who's using a cloud storage website to exfiltrate data from your system, you're also going to get information about that in the Windows Search Index.
All right, and remember how I mentioned we can even enumerate user activity for non-existing files? Cider can help you in that as well. So we tested by interacting with the file and hard deleting the file. The file was not present on the system anymore, but it was interacted with, and hence we can see that we can enumerate the file name, when it was interacted with, the program used in the interaction, as well as the user SID, which we can map to a particular profile in the registry key. Like Julia mentioned, Cider is really fast. We tested it against a total of 9.5 gigabytes worth of Windows.edb and Windows DB files. And as you can see, it parsed it under 22 seconds. It can save you frustration in those time-sensitive matters. And if you use Velociraptor in your investigations, we have released the Velociraptor plugin to help you parse this artifact at scale. But due to the concerns regarding the size of this database, please be sure to read the warning which is mentioned in the description of the plugin before you use the plugin. You can find it on Strauss Friedberg's GitHub repository, and we will also be placing a link in the Slack chat after the talk.
Okay, so that was the bulk of our talk. We do have some key takeaways from you or for you, just to summarize what we talked about today. So the Windows Search Index is really useful. You can enumerate file and folder existence. You can prove file knowledge because you get activity history records with the Windows Search Index. And you can also enumerate a user's internet history, even if they deleted their history in their browser.
And why should you use Cider? Because why not? It's fast and easy to use command line tool, which requires minimum parameters. And importantly, it can parse both Windows 10 and 11 Windows Search Index databases and at scale. You don't have to parse each database one by one, thus saving you from the frustration in those time-sensitive matters. And most importantly, it gives you analysis capabilities for a lesser known but a very important forensic artifact.
There are some questions that still remain unanswered. I encourage you all to do your own research and do your own testing. We still don't know why we can search for file content past what seems to be indexed in the database. We still don't know much about deleted records. More specifically, how long you can wait before you can't recover them any longer. And there's some more questions here that I'll let you read. But again, I really encourage you to look into this artifact because we found it really interesting, really rewarding to do our own research on it. And if you weren't taking meticulous notes or if you fell asleep, shame on you. I'm just kidding. We have a blog post where we've written down everything that was in our slides. So go ahead and check it out. If you missed anything, it's a great blog post. I really encourage you to take a look. Oh, and also follow us on Twitter. We're at Straws DFIR. You can stay updated with all our thought leadership from our talented team.
And we wanted to thank you folks, Partha Alvar and Carly Battle, for helping us to go throughout this research and talk, and Oleg Dolgov and Vitali Ristayuk for developing Cider in such a short amount of time. Lastly, we encourage you to perform your own research for this artifact, but keep in mind your results may vary due to the build numbers used in testing. Thanks all, appreciate it.